Hey, what's up guys? Back again with another machine learning video. In this video, I'm going to teach you some basic techniques for cleaning your dataset so that we can have it in the right state for training machine learning models. So cleaning a dataset involves fixing or removing incorrect data, missing data, incorrectly formatted data, duplicate data, and other types of things. There's a lot of different things that we can do to clean a dataset, but my goal is that by the end of this video, you will know the basics so that you can start cleaning up any basic dataset that you come across. This process of cleaning the dataset is part of a bigger process of pre-processing your dataset as a whole. So besides cleaning the dataset, we also have to take steps like encoding categorical features and feature scaling. All of that is coming in future videos, but yeah, I just wanted to focus on data cleaning in this video specifically so that you can understand what you need to do. And here's a good example of a dirty dataset. You can see that this is a lot bigger than the dataset that we worked with for the simple linear regression model. It has a lot of columns, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 columns. When you get the head of the dataset, which is just the top 5 rows usually, you can clearly see right away that there's missing data. So you can see that you have in, and that's the same thing as having null, meaning that there's no value in these cells. And that's not good. A lot of machine learning libraries will not be usable or perform badly if we have missing values in our dataset. So we need to figure out a way to deal with those, which I'll teach you about. But you also notice that, for example, here we have a column here that doesn't really provide us any useful information. This is just a student ID, which if we're trying to make a machine learning model that can, for example, predict someone's, like if they have diabetes or not, it wouldn't make sense to use the student ID. That obviously wouldn't have any effect on if they have diabetes or not, okay? So one part of cleaning data would be to fill in these missing values or deal with them some other way, but cleaning your data set also involves other different things like dropping columns that aren't even relevant and stuff like that. So before we jump into the code though, it's important that you understand one thing. There are many different ways to clean data, like I said before, but also in terms of code. If you look online, you'll find lots of examples of cleaning data, but a lot of the time they differ in their approach, their syntax, how they do it, what libraries they use, stuff like that. Like for example, you can use dataframes and clean your data just using dataframes, or you can use scikit-learn to clean your data, and there's just a lot of different ways that people do it. So in this video, I will do my best to try and show you how to do this in a way where you can adapt to whatever approach that you see online. Hopefully this will give you a firm basis for doing that, okay? So anyways, let's just get started. Let's jump into the code now to see how to clean a dataset. Alright, so I'm on Google Colab again. I'm just going to go ahead and create a new notebook. So File, New Notebook in Drive. So now we have a notebook where we can start, coding and learning how to clean data. But also I want to go to this link here. This is a dataset that we're going to be using, a sample dataset that we can utilize for learning how to clean data. It's just the medical students dataset. Don't look at the description because this does not line up with the actual data. It's kind of incorrect. But I do recommend using this because it has all those missing values. It has many different types of data as well. I think this is a great example data set to get started with. So I'm going to go ahead and download that and then add it to our notebook that we have here, okay? This data set has, I believe, 200,000 records in it, or rows, whatever you want to call it. You can also see that it's struggling to even load the preview. Here we go. So yeah, it has 200,000 entries. We can take a look at what it looks like. That's pretty useful. All right, so let's get started here. So the first thing that we want to do is go ahead and import our dataset, just like we learned about in the last video. So import pandas as PD because we're going to be using the pandas library for data processing. Then we could use pandas to import the dataset into the data variable. So data is equal to pd.read CSV, comma separated values, and then now we just need to provide the path to that dataset. So it should be just right here. So medical students dataset.csv, and let's just go ahead and do data to see if it works or not. Data. All right, so it works. As you can see here, it printed out our dataset. Something I just want to correct real quick. Last episode, I was doing print data, for example, or print.head. You don't actually have to do print. If you just literally just have it like this, it will go ahead and display it for you automatically, which is really cool. I can't believe I went that long without knowing you could do that. It's kind of crazy. But yeah, because we're not printing it and we're doing it like this, it looks a little better as well. We can Colab will automatically display it for you in a way that looks nice. So yeah, this is a look at our data set. We can see that we have our 13 columns just like before. Student ID, age, gender. You can also see that right away there are missing values in AN. That's how you know that. So the first question is, how can you check for missing data? One simple thing that you can do is data.info. And what this will do is give you information on the data set in every single column. So we can see that we have 200,000 entries, 0 through 199,999. We have each column here, so student ID, age, gender, all the way up to smoking. You can see that for the non-null count, it's 180,000 non-null values, which right away you should see as a red flag, because if there's 200,000 entries total and only 180,000 of them are non-null, this means that 20,000 of them are going to be null, meaning that there are missing values. So we obviously want to deal with those. You can also see the data type of the columns, which is pretty useful. Something that we'll learn about later on is we need to convert these object data types, which is like a string, for example, into actual number values. But another thing that you can do to check for missing values in a data set that you have in a pandas data frame is by doing data.isNull and then .sum. So this will give you the sum of all the null values in every single column. So we can see that every single column that we have in the dataset has 20,000 missing values. Of course, realistically in a dataset, you'll have many different varying numbers of missing values per column, or even none maybe. Someone may have pre-cleaned your dataset. I do recommend using pre-cleaned datasets, of course, when you're learning about machine learning, but obviously sometimes you can't avoid that, or it's just good to know how to do stuff like pre-processing in general, because in the future you may want to clean your own dataset for the first time. So anyway, these are the two ways that you can see or check your dataset for missing values, okay? So now that we've determined that there are missing values in our dataset, we have to figure out how to deal with those missing values. So these are the four options that we have for dealing with missing values in our dataset. Number one, you could just keep it how it is, which is definitely not the correct option, because we need to deal with null values for a lot of machine learning models. Like I said before, a lot of the models don't like when you have missing values, and that just kind of makes sense, right? So approach number one is not a real option. So approach number two is remove the rows with missing data. So whatever row in the table has a missing value, if it does have a missing value in one of the columns, just remove the entire row. So that's a fine approach when you have a really big data set, for example, or in situations where removing some of the rows doesn't really affect the quality of the data. Now, if you have a relatively small sized or medium sized data set, and you remove something like 10 to 20% of the rows in that data set just because they have missing values, obviously that's going to affect the quality of your data because you're missing a lot of data. And data is literally the most important thing when you're doing machine learning. More data is usually correlated with better results. You always want more data, right? If your data set is huge, where you have hundreds of thousands of records, potentially removing some of them isn't a bad thing, right? But in our particular example, even though we have 200,000 entries in our data set, we know that per column, 20,000 of them has missing values. So that means that if we remove all of those rows, which could potentially be 20,000 or more rows, that would be 10% of our data set, which I think is a lot. So that might not also be the best approach. So the third option will be to remove the whole column that has missing data in it. This is another really extreme option because some of these columns that you have in your dataset are there for a good reason. They have meaning to the prediction that you're trying to make. So if you remove a whole column of your dataset, then obviously you may not be able to make meaningful predictions to your target variable. We're going to learn about in the future how to determine what features in our dataset or columns in our dataset mean the most to our result, but for now that's probably not the best approach. So the last option will be to impute the missing value, which simply means that you want to fill in the missing value with some other number or piece of data. Now, one of the most common ways to impute a missing value is by taking the mean of the column as a whole. So for example, we have this height column here, and we have a missing value in row number 4, index number 4. You can impute a value for this or find a replacement for this by taking the mean of the entire column. So add up all the non-missing values and find the mean of it, and then just replace every single missing value in that column with the average. Other options is like the mode, for example, or the median. You can do those as well, but probably the most common basic one is just to do the mean, okay? All right, so let's say we do want to do options 2 or 3. So option 2 is remove rows with missing data. An easy way to do that with pandas is just to do data is equal to data.drop in A, and then we could do axis 0. So axis 0 is how you specify that it's the row that we're trying to target. If you do axis 1, that's the column. So if we have axis 0, whenever we run this will drop every single row that has a missing value in it. If we set it to 1, this will drop every single column that has a missing value in it. So let's test it out. So first of all, we're going to run this again so we can verify we have 20,000 missing values per column, right? So if we go ahead and run this now, it should have dropped every single row with missing values. So let's go back up here and run this one. And now you get 0. So every single column has 0 now because all the missing rows were removed. And we go back up further, and let's just go ahead and run this one again. We can see that our data looks a lot different now. So it actually removed a lot more than 20,000 from our data set. Now we only have 50,000 roughly entries in our data set, which is that's a lot of data to have removed from our data set. So, I mean, we have solved the problem of missing values. Now we don't have any non-null values, as you can see when we run this. But we now have a data set that doesn't really do anything for us because we have removed a lot of the useful data. So that's not the best approach. So let's go ahead and run this again, re-import the data, verify we have all the data just like before. Good. All right, so we're back to that state how we were before. Now let's change this to access 1 and let's see what it does. Boom. Let's run this again. And look, now you have no columns at all because every single column had missing values in it. So we've totally destroyed our whole data set, which is obviously not the best approach. So let's go ahead and reset it again. Let's go back down here. And I'm going to comment this one out just for safety in case we run it accidentally. So now I want to teach you guys how to impute missing values, which means again to replace missing data with a value. Luckily, Pandas makes it really easy, so we have our data in a data frame already. So let's say that we want to impute missing values for the age column. So every time we come across a NaN value or missing value in our column here, we replace it with the mean of the whole column. So to do that, we do data. You specify the age column. We do is equal to data, age again, dot fill NA. So instead of drop NA, it's fill NA. So we're filling in the missing values. And now you're just going to tell it what to fill it with. So we're going to do data, age again, dot mean. So this will replace every single NA value or missing value with the mean of the entire column. So it's going to do that for every single one, and then we're going to reassign the column to those new values, essentially, okay? So let's run this one again. So we get 20,000 missing values for the age column. Let's run this now, and let's go back up here and run it again. And now we have 0 missing values for the age column. So let me just go ahead and run data.head again. And look at that, the missing value is now filled in for the age column. That's great. So this is for imputing a single column. Now I'm going to show you guys how to impute multiple columns. So imputing multiple columns at once. And this is useful because, of course, we have a really big data set. A lot of them are missing values per column. And it makes sense to kind of do it in bulk. So let's say that we want to impute the mean for not just the age, but also the height column and the weight column. So let's try doing that. So we're going to do data. And now instead of just a single multi-dimensional array accessor, you want to do it like this. So another bracket inside of that. And now we can provide a list of the columns that we're trying to access. So age. Well, we've already done age. Let's just do height and weight. So height and then weight. So this is just targeting the height and weight columns of our Pandas data frame. So let's take this again, copy it, replace it here, and now we can do fill NA, and then now we could take this again, so paste it yet again and do the mean. So now this will do the same exact thing as above. It will calculate the mean of each of these columns, and then now every time it finds a height that is missing in the height column, it will replace that missing value with the mean of the entire column, and then same thing for weight. The only difference between these two lines of code here is the syntax is a little different. Here we're specifying a single column, so we only need one bracket, but down here, since we're specifying multiple columns, we need to specify it as a data frame, which is kind of like a multi-dimensional array, so we just use 2 brackets. It's kind of weird, but I think the more you do this, the more you'll remember it, and that's also useful to have these Python notebooks anyway, so that you can always refer to it. But anyway, with that said, let's go ahead and try this out. So I'm going to go ahead and copy this. And we're just going to move it down here. So currently height and weight has 20,000 missing values per column. Let's run this now. And look at that. So now for height and weight, we have 0 missing values because we have calculated the mean for both of those columns and replaced them. So this is imputing multiple columns at once using data frames. Like I said before, the mean is just one way to do it. You can also do the mode, for example, or the median. So you would just do like median, or even the mode you should be able to do. Anyway, so that's how you can impute missing values using Pandas data frames. Now I'm going to show you guys another way to do it, which is using the sklearn or scikit-learn simple imputer. So first of all, there's this really useful link here where you can view the documentation for the simple imputer on their website. It gives you all the information about all the parameters you can provide and just, examples on how it works and stuff like that. So that's useful if you want to check that out. But to actually use it, we're going to go ahead and do from sklearn.impute import simple imputer. We're also going to import numpy as np. So right here, we're going to do the same exact thing we did above. We're going to replace the missing values with the mean of the column that we're trying to target. Before we do that, we're going to need an imputer. So we're going to make a new instance of imputer. So imputer, simple imputer. We're going to tell it the strategy. So the strategy is going to be the mean strategy. You can see all the strategies on their documentation. So strategy, so if mean, then replace the missing values using the mean along each column. Can only be used for numerical data. You also have the median, which is for numerical data. You also have most frequent, which is useful for string data or numerical data. And then you also have constant, which is where you can replace every single missing value with a specific value that you want to specify. So we're going to set the strategy to mean, and then now we're going to set missing values. We're going to do np.nan. Then for this one, for missing values, this is just telling it what we want to replace, and we can use numpy to specify np.nan, which is just a placeholder for missing values. Anyway, so now that we have an imputer, we can go ahead and use it. The way that scikit usually works is you usually want to fit on the data, and then you want to transform the data. So first we're going to do imputer.fit, and we want to tell it what we want to fit it to, so what data we're trying to fit. In this case, we want to tell it what column we want to fit our imputer on. So we can do the temperature column if we want to, so this, because this one has missing numerical data, so we'll do temperature, right? So right here you can do data, bracket, bracket, and then you can do temperature. And the reason you want to do double bracket is because scikit-learn expects it as a data frame, which is a two-dimensional type of thing. If we were to do one single bracket, this would be technically a series, which is in Pandas like a column. So anyways, yeah, just use double bracket because it wants it as a two-dimensional Pandas data frame. What's also nice is that you can do multiple if you want to. So you can add temperature, you can do age, like that. So it makes it easier to add more columns as well. But anyways, now we have used our imputer to fit it on the temperature column. So now we can go ahead and replace the data in our temperature column by doing data temperature is equal to imputer.transform data temperature. So all this is doing is taking the temperature column as a Pandas data frame, transforming it using the fit that we did earlier, so it knows the mean and all that internally, and it's just going to replace all those missing values with that mean, and then return it back to us, and then we can replace that temperature column with that new data. So let's go ahead and run this. No exceptions, that's good, and let's go ahead and print out our thing here so we can see if there's any missing values now in the temperature column. And look at that, there are not. So now the temperature column has 0 missing values because we have used the scikit-learn or sklearn simple imputer to replace all those missing values with the mean of the entire column. So that is how we can impute the mean for missing values using scikit-learn for numerical data. Now, for categorical data, it's a little different. A good example of categorical data is for gender. So you have male and female, those are strings, but these are the only two options. Same thing for blood type, you have O, B, A. Those are not numerical, so imputing the values for that it has to be done a little bit differently. You can still use the simple imputer, but as we saw before, for the strategy, the imputation strategy, you cannot use mean or median. That's for numeric data. We have to use other approaches like most frequent or constant, but most frequent is a good choice. So this will simply replace the missing values with the most frequent value of the column, okay? Let's say that we want to impute the missing values for the gender column. So all we got to do is pretty much the exact same thing, except that we just have to change the strategy to most frequent. So imputer is equal to simple imputer, and we're going to set the strategy is equal to most frequent, like that. And then we'll set missing values is equal to np.nan from numpy. And then just like before, we want to fit the imputer on the data that we're trying to impute. So we're going to do imputer.fit, and we're going to specify the column in our data frame, which will in this case be gender. And then we'll do data gender is equal to imputer.transform data gender, just like that. So that's literally all you got to do. So let's go ahead and run this now. You'll notice that when you run this, you get an exception or an error. And this is because the dimension of the array that is returned from transform is 2D, but we're trying to store it in a column, which is 1D. And for some reason it works whenever we do it with the mean strategy with numerical values. But whenever we do it with the most frequent strategy, we get this issue and it doesn't like automatically convert it for us, which is really annoying. So what you could do is ravel, and what this will do is automatically convert the 2D array into a 1D array for you. So run this and now it works. And now we can go back up here, copy this, move it down here, and we can go ahead and check, and now we can see that there are no longer any missing values, which is good. Something that you can actually do, which is kind of cool, is combine fit and transform into one. So we can just change it from fit to fit transform, and then we can go ahead and assign it like that, and then we could delete this one. So now it's going to go ahead and do the fitting and the transformation all in one go. So let's test it out. So we're going to go back up to the top, reset the data by re-importing it. We're going to go ahead and verify. All right, so everything is as it was now. So we're going to scroll down, and let's go ahead and run the imputer. Okay, so now temperature should not have any null values, and if we run it, there we go. Now we have temperature with 0 missing values. So that's just a way to make it a little bit more concise if you want to do that. Alright, so that's how you can impute missing values in your dataset. That's just one way to clean up your dataset, is by replacing the missing values with actual values. In this case, it could be the mean, the mode, the median, or the most frequent for categorical data types. Another thing that you could do is remove duplicates, because sometimes in your dataset you may have duplicates, meaning that all of the columns have the same value in it. So we could see all our duplicates by doing data.duplicated.sum. So this will just tell you how many duplicates there are in the dataset. There we go, so we have 7,644. And to remove those duplicates using pandas is actually really easy. We just do data is equal to data.drop duplicates. There we go, so that will drop them. Now they're gone, so let's run it again, and now we have 0 duplicates. All right. And another thing I want to show you guys is how you can remove columns. So like in the beginning of the video, I told you the student ID column is not really useful. That would have no effect on predicting something like their diabetes or whatever. That would have no effect on whether they have diabetes or not, if that's what we're trying to predict, for example. So to remove that column, because it's irrelevant, we could do data is equal to data.drop, and we can specify the column name that we're trying to drop, so student ID. And then we're saying the axis is 1 because we're trying to drop a column, not a row. So this should drop the student ID column. So now we can do data.head after that, and let's see what we get. There we go. So student ID is no longer in the dataset because we dropped it. Alright, so that's pretty much all the basic stuff I want to teach you for data cleaning, for cleaning your dataset. Now we know how to detect when there's missing values in our dataset just by calling data.isNull and then using sum. We know how to handle those missing values. We can keep it how it is, or we can remove the row or the column, or we can impute the missing data. When we impute the missing data, we kind of have two choices. We could use pandas, so this is a data frame, right? And we're using the pandas fill in a method to fill in the missing values with the mean. You could use that if you want to, it's pretty easy. But we also learned how to use scikit-learn's library, using simple imputer to impute the mean. And luckily, scikit-learn actually accepts data frames as input to its methods, so that's why we're able to do something like this, where we do data and then specify the temperature column. But scikit-learn was actually originally made using numpy arrays, so you're going to see a lot of examples online of it using, like simple imputer, for example, not passing in a data frame, but using a numpy array. And a lot of people actually recommend that you do that, even though it now supports data frames from pandas. They recommend you still use numpy arrays because it's more mature, it's been around for a lot longer, and that's really up to you. I mean, I kind of agree with that in a sense. If it's more mature, then you might as well use it, and a lot of the examples online also use it. But data frames are also really easy to use. It's so nice that you could just tell it what column it is and just provide it like this, and also set it like this. So it's really going to be up to you how you want to do it, but I want to show you guys how you can use the simple imputer also using numpy arrays rather than data frames, okay? It's also good because we're going to be using numpy arrays a lot in the future anyway, so I think it's good you know how to, kind of work with them. It's really not that different though. You're literally just passing a variable same as before. We're just telling it what indexes. So what I'm going to do is make a new notebook just for that real quick, okay? I'll be right back. Okay, so we're going to import our dataset same as before using pandas. Also import numpy because we're going to be needing that. Now we're going to go ahead and do what we did in the simple linear regression video. We're going to split our dataset into an X matrix and a Y target variable vector. So data.iloc. Now for the simple example here, I'm not really trying to predict anything. Normally I would have the target variable in the last column. It doesn't have to be, but normally that's where I would have it, or people would put it. So we're just going to pretend smoking is our target. So we're going to do same as before, all the columns except for the last column, okay? So we're going to do colon -1, so that will give you all columns except the last one, dot values, which will convert it to a numpy array in the form of a matrix in this case because we have multiple columns. And then we're going to do y is equal to data.iloc, and then we're going to do all rows, and then now we're just going to do -1 dot values, which will give us the last column as a numpy array vector. So we run that now, and then we can go ahead and print x to verify what it looks like. There we go. So here's our little matrix, and we can also do y. There we go. Now, just like before, we are aware that there are missing values, and we could test that out again by doing data.isNull.sum, and we see that there's missing values for every single column. So let's say that we want to impute the missing values for age. To do that, we're going to go to do from sklearn.impute import simple imputer, just like we did before. Then we're going to go and create a new imputer is equal to simple imputer. This strategy, just like before, is going to be the mean strategy. And then missing values, we can go ahead and do np.nan. So now if we want to go ahead and impute the values for the height and weight columns, before we would just give it the columns, the name of the columns for the data frame, and we would just pass the data frame to our imputer. But since we've split our data frame into the x and y numpy arrays, we need to do it on x, right? So the syntax is a little different. We can just directly tell it the indexes of the rows and columns that we're trying to do the imputer with. So we're going to go ahead and do x, and then all rows. Then now we can give it the range of columns that we're trying to do this for. So in this case, since we're doing height and weight, it'd be 0, 1, 2, 3. So start at 3, and then 4, so 3 to 5, because the last index is not inclusive. So we're going to do 3:5. And then we can go ahead and do imputer.fit transform, and then x, and then the same as before, so colon 3 to 5. So just like before, what this will do is fit the simple imputer on our columns that we specified, so 3 through 4. And then also it would transform the data within those columns and return it. And then we're going to replace the data by reassigning it like that. So it's the exact same syntax as before, except that we're not using a pandas data frame, okay? And what we can do is actually convert it back to a data frame temporarily, just so that we can see the data more easily, to visualize it more easily, and also check to see if there's any missing values, just like before. So we could do that by doing pd.dataframe, passing the x matrix. Let's go ahead and print it out just to take a look real quick. So now we can see for weight and height, there are no missing values, it looks like. But we can verify that, of course, by doing isNull, and then sum, just like that. And we can see, yeah, there we go. So for columns 3 and 4, we have 0 for the missing values. So there are no missing values because we've imputed them using a sklearn simple imputer. Now you may be wondering, how can I do just one column? Because, you may want to do that. So instead of providing a range here, you just want to target one column. Let's say we do column 2, for example. That would be for the gender column, looks like. So 0, 1, 2, that's for gender. So that would be a different strategy. That would be the most frequent strategy, since it's a categorical data type. And then we would change the index here as well. But this won't work because fit_transform expects a 2-dimensional array. And we have just targeted a specific single column, so that would be a 1-dimensional array or a vector. So what we have to do is reshape it so that it's 2-dimensional, so it's in the format that this method accepts. All we have to do is do -1 and then 1. So all that will do is take this numpy array, which is a vector, reshape it as a 2-dimensional matrix, and then pass it into this fit and transform method, so it will actually do the imputation. But now it's going to be given back to us as a 2-dimensional matrix or numpy array. So we want to go ahead and reshape it back to a vector because that's what it's expecting here, since we're targeting one specific column. So we can just do that by doing .ravel. That will automatically do it for you. So now if we go and run this, hopefully it should work. No exception. So now let's go and run this now. And now you can see for index 2 for the column, it is 0 for missing values because we have imputed all of the genders that are missing. So this syntax is definitely a little more, I guess, confusing. It can be a little more confusing because we're not specifying it by the name, which is often convenient. It is nice because you can really easily just give you the exact rows and indexes that you want to target. You just have to be aware of the format of your data. Like in this case, we had to reshape it from a vector to a 2-dimensional matrix, and then also shape it back. So that's kind of a pain, but I think as long as you understand what form the data should be in, it shouldn't be too much of an issue. And also, of course, I'll have all of the source code for both of these notebooks that I've created in this episode in the description below, so you can check it out and have it, just have it on standby for reference, whenever you're working on your machine learning projects. It would be insane to have you remember all that. So yeah, it's good to have it just standing by in case you ever need it. And yeah, now you guys should know how to do some basic steps to clean up your dataset before doing any machine learning. So now you know how to check for missing values, impute missing values using both Pandas and scikit-learn. And when using scikit-learn, you also know how to use both Pandas data frames and also numpy arrays, if that's the method that you want to go with. And I also showed you guys how to drop columns or specific rows, and also remove duplicate values and detect duplicate values. So hopefully you guys learned a lot. That was all very important. And if you have any questions or anything is confusing, let me know in the comment section below. And I will see you guys next episode. So that's it for this video, everybody. I really hope you learned something new. If you liked the video, please hit the like button, and if you want to see more, hit that subscribe button. Make sure to also check the description below for important links to code and other resources, but also really important, join our Discord. We have a big community of over 5,000 programmers, and it's a place where you can find new friends or get help on any code that you're stuck on. If you want to support what I do on this channel, please consider hitting the join button below, and this will allow you to support my channel for as low as $1 a month, but there are different tiers to choose from if you want to. For anyone that becomes a member on my channel, you get a special rank on my Discord server, early access to new videos, and you can just see yourself on the screen right now. So if that sounds cool to you, feel free to join. If you don't want to, that's fine. If you can't, that's okay too. I really just appreciate you watching the video anyway. Thank you so much. And that's it. Peace.